Okay, while we were gone, I realized that I had a small problem. My notes weren't quite right. I changed to pin 4 and pin 5 instead of pin 8 and 13. So I'm going to make that change in the comments. Of course, there's no need to re-download that to the Arduino, because when you download your program to the Arduino, it doesn't save the comments anyway. The microchip, microcontroller there couldn't care less about my English comments. It barely cares about the instructions that I've made here. After, like I said, they've got to be converted into something else. So let's see if we can now get this to play some music along with flashing some lights. And then we'll get it to flash lights the way that I want it to flash lights. Let me clean up some of the spaces to start. Don't need quite so many. It doesn't really matter what order your routines are in. I kind of like having the interrupt subroutines before the main loop because they're active anyway during the main loop. But we need some code, and you guys have already succeeded in causing your Arduino to play sound, and you found that you can connect the speaker through a 1000 ohm resistor to a pin and download code that works. So I'm going to reconnect mine, and like I said, I'll show the circuit in Fritzing for the Anderson students so you can understand what's going on. Anyway, I made a link in Blackboard that I think most of you found to some music that played, or a program that played the Super Mario Brothers theme on the Arduino. So that was kind of neat. Most of you probably still know what Super Mario Brothers were. You probably didn't. You may or may not have realized there were actually Mario Brothers games before Super Mario Brothers. But anyway, so this is what's going on. We've got the, and by the way, this is a circuit built in Fritzing. Fritzing is just a software that allows you to draw this stuff easily so that you can explain what you're doing to other people. So you can see that there's a buzzer essentially hooked up to an output pin going through a 1000 ohm resistor back to ground. And the code that they've got here will play the Mario Brothers theme. So let's just copy the code and see if it works. So if we copy this code, let's see. Basically what happens is they declare several arrays that have the song in them, essentially, the timing and the notes. And let me make a new file because I'm just going to make this, I'm going to do these separately. I'm going to make it play music, and I know that the New Albany students have already figured this out, so I'm sorry that this is a bit of a repeat for you. But for the sake of the Anderson students, I do need to go through this. So let me Control A, Control V. So now we've got code that in theory will play the Mario Brothers theme song. The only problem is it doesn't work because it refers to a file called pitches.h. If I try to download this to the Arduino, it makes me save it first. And so let's call it Mario Brothers theme. And as soon as it tries to compile, it'll say, hey, guess what? We don't have pitches.h. Oh, well, also it says something else. Error compiling for Genuino. Yeah, no, there it is. It's complaining about not having pitches.h. If you go back into the article, you'll notice that pitches is just basically the frequencies of all the different notes. You can refer to them as C4, C2, A, whatever, all the different melody or notes, the pitches, A through G on, you can think of it as a keyboard. Anyway, so they note somewhere that you need the pitches.h, and where was it? They referenced it. Here we go. Download pitches.h from the public domain code here. So let's see, we're looking for pitches.h. Here we go. And we can just say get that code. So there it is. So I'll just save as. And let's see, I need it to be pitches.h. And New Albany students, I'll let you chime in on this. Where do we need to put this so we can actually reference it in the Arduino software?
In the same folder as the file you're working on.
Exactly. So let's go to the folder where we're working on code. I think that's in documents. For me, it's in documents in an Arduino, if I remember right. Yeah, there we go. Mario Brothers theme, so it needs to be saved there. Okay. And let me open it up in the Arduino so you can see it. Or in the Arduino IDE. That's some code I made before. This is a different place. That's in my documents. I want Arduino. There we go. Okay, now what exactly does this code do? Oh, how did I do that? Oh, it worked. It just opened everything in that directory. Pitches.8 just defines the frequency of each note. So B, the lowest note that this references in register 0 or octave 0, is 31 cycles per second. C is close to it, it's at 33, and so on. They probably have A 440 in here somewhere, which is a standard tuning. Yeah, right there, A4. In the fourth register or the fourth octave, it's 440 cycles per second. If you know something about music, that might be something you've heard of. You can actually define A to be a different pitch if you want. A432, I think, is the other option that's common. It doesn't really matter. What matters is the relationship between the frequencies need to be set so that it'll sound like music to our ears. So anyway, there's pitches.h. Let's try compiling it now. Let's check and see what happens. Still doesn't like it. And the reason it doesn't like it is because it still can't find pitches.h. Now, let me show you something. In doing a little bit of digging, what you'll find is that if you put quotes around this instead of the greater than less than sign, it should work. Let's check it now. And I've forgotten the details of why. You can find this in the comments below. Yeah, it likes that. If you look in the... well, I've already closed it. Let's open this up again. Oh, no, it was here. If you look in the comments below, you'll notice that some people say that they can't make it work, and if you put quotes around it, it works. And they explain why, but I don't really remember why. It doesn't matter for my purposes. It works now. Now, the only problem is they've got pin 3 as the melody pin. So if I download that to my board, it won't work because I don't have my speaker hooked up to pin 3. I've got my speaker hooked up to pin 12. So let me change that to 12. And if you notice down in the code, they did something kind of dirty. They hit the pin directly. If you look, yeah, see, they've got an LED output. I don't care about an LED output. I'm going to have my own LED, so I'm going to get rid of that. But instead of referencing the melody pin, they referenced the pin number directly. So let's fix that. Okay, let's see what else they've got in their code that we need to change. They've got digital write to pin 13 high and low. What they're trying to do here is turn an LED on and off. That's where they turn it on. Here's where they turn it off. I don't care about that. I'm going to have interrupt routines doing something like that. So there we go. That should take care of it. Okay. I think that's everything we need if I remember right, so it'll actually play this. So let's try it and see. Uploading. There we go. And Anderson students, I don't know if you can hear that coming through the microphone on my computer, but the little buzzer I've got here is playing the Arduino theme, or playing the Mario Brothers theme song. And of course, you guys here in New Albany have already figured all this out. Okay. So now we have code that plays music, and we also have code that will interrupt the music and flash LEDs. Now it's not quite flashing the way I want it to yet, but I'll fix that in just a minute. Let's see, we don't need 2 of these open. So now we've got this code over here that will interrupt and turn LEDs on and off, and we've got code that will play music. Let's put them together. I think probably the easiest way to do that is to simply copy the interrupt stuff over to the other code, because the song code is longer. So here's the song code, and basically everything I had was setup stuff, so that's where it needs to go. Alright, so what do they have here in the song? Well, they've included a file. They've defined melody pin as 12. This is a way that you can avoid using memory space. So anywhere that the compiler sees melody pin spelled like this, it'll replace it with the number 12. Now that's annoying, so I'm going to disconnect the speaker for a minute. Okay. Melody is just an array that defines the melody for the code being, or for the music being played, and then this is the speed. This is basically how long each of the notes last. So it's another array. Here's an array for a different melody and how long each note lasts. And now we're in void setup. Okay, so let me give myself some space. This is going to get a little messy, but I'm just going to paste in the code that I had a minute ago. Now let's see what all needs to go into setup. There was a void setup, and I can't have two void setups, so let me cut out the stuff that goes into void setup and put it into the other one. Let's see, and I'm hoping this breaks the code. Thank you. Okay, Control X. That makes sense. We've got the open and close here, so let's put that down into void setup. The original void setup wasn't very long. Notice they put a void in here. You don't have to. What that means is that setup is not going to be passed any information. We can just get rid of that. It doesn't matter. Paste it in there. So let's see. Looks like we're going to set the pin mode of the all our pins, and so now we're going to have a pin mode for the buzzer, but also pin modes for the LEDs. So let's paste that in. So setting pins as outputs. Okay, that makes sense. Clear interrupts, set up our timers, allow interrupts, and then go into loop. That's all well and good. I would like to put my subroutines that are the interrupt service routines, I'd like to put those below void setup. I just feel like that's a better place for them. So I'm going to cut them out and put them in before void loop, but after the setup. Okay, so all I've done is cut things and move them around so that it makes sense, hopefully. Now we don't need the original void setup, so let's get rid of that. I think that's about it, isn't it? We've got variables that are declared here, but that's the appropriate place for them. It's before the void setup, so these are global variables, just like we've got these global arrays up here for the melodies. And I think that's good. Is there anything else we need to do in order to make this work? Let's see, all the setup's done, the interrupt service routines are done. We've got a loop that is supposed to play songs. It played before. Let's see if it'll play now. Before we download, let's check the code. It'll do a test compile. It's okay. We'll tell it to run. I'll plug the speaker back in and we'll see what happens. Now I noticed that the LEDs are flashing as they should. Now listen to that. Come close so you can hear it. I hope the Anderson students can hear the song. Do you hear what's going on? It doesn't sound right. What seems?
It's going too fast.
It's going too fast. Why is it going too fast? What happened?
It's going at the timer speed, not at the song speed.
Almost. You see, normally we don't get to mess with timer settings like we've messed with them, right? We've changed timer 0. That's really annoying now. Okay, so it's just playing way too fast. Something happened. Well, what did we do? Well, we messed with two timers. We set some very basic registers for timer 0 and for timer 1 that we might not should have set. Well, why would that affect the song code at all? What's going on? Well, if you notice, in the song code, they use a command called delay. How do you think the delay command works? Based on a timer, exactly. We just messed with some switches on the timer, and now delay doesn't work like expected because we messed with it. Okay. If you dig and you start reading about what delay references, it uses timer 0. And we messed with timer 0 and we shouldn't have. So, the fix is simple. I left it in on purpose so that you can see that when you start getting down to low level in the microprocessor, you can break something else. Okay? So if something breaks, you might suspect the code that is low level code is causing the problem. I really didn't have to do anything with timer 0, right? I didn't have to change its speed, its default speed. I could have just gotten rid of it because all I really needed was timer 1. And that's why I said earlier, when you're dealing with low level code and you're really not sure how it works, try to use the minimum that you need. That way you hopefully don't step on toes somewhere else in the code. So I really didn't have to change it. And I really didn't have to have this interrupt service routine for timer 0. Right? So let's get rid of it. I really only needed timer 1. So I'll leave it in. Now, I think that should fix it. So let's download it and run it and see what happens. Oh, we don't need the other toggle variable. We have an extra variable. It's always good practice to get rid of stuff that you're no longer using. It's better practice to comment it out and make sure you're not using it, not do what I just did. But it's also good practice to record. Did I start it? Yes. I thought I forgot to start the recording. Okay. Done uploading. Let's see if it's happy. Ah, we have a nicer song now. Notice we've got only one LED flashing. We don't have the other one on. Why?
Because you're only using one timer.
Only using one timer. We got rid of that whole interrupt service routine that was turning that light on and off at 1,000 times per second. Okay, so life is better. We've got a light flashing while music is playing. So it's like one's in the background, which is nice. That's what you need. But I said I didn't just want to have one light flash. I wanted to generate a random light for a random amount of time, right? Now the way I could do that in the interrupt service routine, let's see. I don't want to just digital write high and digital write low. That's not really all that fun. What I want to do instead is every time I come into this, I want to generate a, well, potentially, I want to generate a random LED. So I'm going to need more than what I've got. First of all, I've got 8 LEDs. I'm only playing with one. So let's fix that. Let's go up wherever the information is. Here it is. Pin modes. We need a bunch more of these. So copy, paste. And I've got 8 LEDs total. So there we go. So pin 4, 5, 6, 7, 8, 9, 10, and 11. Let me double check that. Yeah, those are all LEDs for me. So I'm going to set the pin mode on all. Now, it would be cleaner to name them LED 1, LED 2, and so on, so that if I decided to switch pin numbers around later, I could just switch it easily. But for now, this is fine. And what I'll do, I won't actually upload this code when it's done. What I'll do is I'll actually change it. I'll define LED 1 and so on, right? And so it'll be even better when I upload it. But I don't want to waste time on that right now. I want to get this, I want to work up the algorithm for doing this. Now, remember that this routine is being called 10 times every second. So all I have to do when I get into this routine is decide, number one, are we finished with the random amount of time that the LED was supposed to be on? If so, get another random LED and turn it on, turn off the current LED. That's all I really need to do. And then it'll be called 10 times a second, and that'll happen over and over again. So let's see. We've got a digital write high. Let's get rid of that. Okay, I wrote this before, so I'm just going to write it. I need something that counts how many times we've gone into this subroutine. Does that make sense? So I'm going to make a variable I, because it's common to use I as a counter variable. So I++ just means take whatever I is right now and add 1 to it. And what this will do is it'll just count how many times I've come into the subroutine. Now, if I is greater than or equal to, that's what this means, greater than or equal to, not just equal to time count. Let's do it that way. The speaker's getting annoying again. There. Now what is time count? Well, I'll define it later. Basically what I'm going to do is I'm going to make a variable that says, okay, choose a random amount of time, 1 through 10, and let's let the LED stay on for that time. That's what time count will represent. I'm building this as I go. In other words, if we've come into this routine so that enough time so that we've accomplished the time on for the LED, then we need to select a new LED. So let's say digital write current LED, and I'll declare all these later, as low. I can't forget to turn off the LED that's on when I come into it. It's time to turn on another LED because the time has elapsed. That's what this statement says. The time that LED should be on has elapsed, and so I need to turn on another one, but let's not forget to turn off the current one. And let's make a new current LED equal random, that's the function, and I'm going to say 1, 11. Actually, no, I'm not going to say that. I'm going to say 4, 12. And I'll explain the syntax of that in just a minute. I need to select a new LED, so I'm going to select a new pin. Please ask questions if you have them along the way. I know this doesn't make sense. When I get it done, it might make a little bit more sense, but along the way, please feel free to ask questions. So random is a function that will generate a random number, and I can have it generate between a low and a high. Well, the low is going to be pin 4, because that's my lowest output pin for my LED, okay? And the high pin, if you say 11, which is the highest pin that I've got an LED on, if you say 11, it'll never select 11. In fact, I'll show you that. I'll make it 11. I need to go 1 beyond, because it's up to but not including. Does that make sense? So it includes the lower limit, but doesn't include the upper limit, and that's just a quirk of the random function in Arduino speak. Okay. So now what have I done so far? Well, I've turned off what LED was on, I've chosen a new LED, and now I can turn on the one that's been selected. Why not, right? I've selected a new LED, may as well turn it on. I will set I to 0 because we haven't counted this LED on for any service routines. Right, we've not gone into the service routine while this current LED is on, so I need to reset that count. And is there anything else I need to do? Yeah, I need to decide how long this new LED should be on. So let's say time count equal random, and I need to select a number of periods, a number of interrupt service routines between 1 and 10, right? Because I want the LED to stay on for either 1/10 of a second, 2/10 of a second, 3/10 of a second, or so on. And I know that I go into this service routine 10 times a second. So I'll select a number between 1, and what do I need for the high limit? 11, exactly. So now, do you understand what's happening here? Let me explain it. I'll point with the mouse. Now let's think about this. When we're just starting the program and nothing has happened, we're going to have to declare all these things. We're going to have to declare I, time count, and so on, and they will have to all be volatile. So let's go take care of that. We've got what? I, time count, and current LED that are not yet defined. Let's go do that. Let's see, so that should be wherever all the other declarations are. We don't need toggle anymore. And these are going to be numbers, so I'm going to make them ints, integers. So we'll make something called I, and we'll set it to 0. And to save ourselves some time, let's just copy and paste. I needed another one called current LED. And I needed, what was the other one I had? Time count. Okay. Now time count could start at 0, but current LED starting at 0 doesn't make sense because it would never take on the value of 0. In fact, time count would never take on 0. At minimum it would be 1. Current LED would be one of the pin numbers, what, 4 through 11? So let's just make it 4. It doesn't matter, it's going to be changed later. Okay. So we'll always start on LED 4 and we'll leave it on for 1/10 of a second. But when we go into this routine, what will happen? Well, I is 0, so I plus plus. Now I is 1. I equals I plus 1, so I is equal to 1. If I is greater than or equal to time count, well, I did initialize time count to 1, didn't I? So I, in fact, is equal to 1. So we will go into this, and we will digital write current LED low. So LED 4 will be turned off. It'll already be off anyway, so we'll never see it come on. Fine. Current LED will select a new LED between pins 4 through 10. Right? We won't select pin 11, which is a bug. I want you to see that happen. We'll digital write current LED high, so whichever one selected, we'll turn it on, and we'll reset I. We haven't gone into the routine. We haven't had that LED on for any time. And we'll select a random amount of time for the LED to be on. Okay, the next 1/10 of a second later, we add 1 to I. So now what is I equal to? 2. I is 2. Let's say that we said time count, we issued the random command, and it came back as 4. Okay, so we wanted that LED on for 4/10 of a second. Fine. So time count, well, I is not greater than or equal to 4, so we just go out of the service routine. We come back the next second, or next 1/10 of a second, right? Now, I plus plus, I is equal to 3. 3 is not more than 4. We leave the service routine, go back to the main code. Finally, we get to the point where we've come into this the 4th time. Now I is equal to 4. These two are equal. Oh, so we digital write the current LED low. Well, the current LED is whichever one was selected at random before, right? We turn it off, select a new one, digital write that LED high, reset our count, okay, and then choose a new random time. Does that make sense? Did I have to do it in that order? No, I could have done this. I could have put time count redefinition here, which probably would have made more sense because I'm choosing a random LED for a random amount of time, and it probably would have also made more sense to set I equal to 0 here. Because certainly, if we get to the point where the if is satisfied, where it's true, it's time to reset our count, right? We've accomplished all the time that LED should be on, so we need to start the count over, counting service routines over. Okay. So now I think this will work. I don't think I've got any bugs, but let's try it. Let's write it. It thinks that it's going to upload. Okay. Now let's see if we've got sound. We do. So the LEDs are coming on. They don't certainly stay on for a second sometimes. Sometimes they stay on for what seems like a full second. Let's see. Let's see if we can note which LEDs have come on. I haven't seen these two come on yet. That one. So now this one hasn't come on. Why didn't that one come on? Number 11, right? That random was not including, it's just up to. Now I don't know if the Anderson students can hear it, but the speaker is playing the tone and the lights are lighting up. So we've got a bug, and that is this random function, like I said, goes up to but not including. So let's change it. We'll re-download. Now that upper LED is coming on. So now I'm able to flash lights at random for random amounts of time and play music at the same time. Okay. Any questions on this?
Where's the association between the current LED and the pin routes?
Okay, good question. Current LED is a variable, right? Where is it? It's an integer, and I started off at 4. So it begins pointing to pin number 4.
Right. Where's that association?
Oh, it's in the pin modes.
In pin modes?
Yeah, so if he scrolls up, so he's got pin mode 4 through 11.
Yeah.
And so when you do digital out 4, it's calling out pin 4.
But current LED could take on any number between 4 and 11. Whichever number it takes on, it's pointing to that particular pin, which is hooked up to an LED to turn that pin on. Does that make sense? In other words, if I simply say down here, digital write 4 high, it'll make pin 4 go high. If I say digital write 5 high, it'll make pin 5 high. And those pins I've got hooked up to LEDs. So current LED can be any number between 4 and 11.
So the fact of that the certain number that is in the first
Variable.
section of that, whatever's
Oh,
inside
that-
the
that
pin
command?
system,
Right.
what is associating that with
That's right.
the pin.
Yeah, whatever number's in here tells digital write which pin I want to make low or high. Good question. Anything else? Well, one thing I'm going to do, I'm going to change this so that 4 through 12 are not in here. Instead, I'm going to make it, I'm going to make it defined. So I'm going to, instead of having 4 through 11 here, I will make it defined. And I'll start it now. You can watch it all the way through if you want. But I really don't like using up or having things that are not easily changed. So I'm going to say LED 1 is defined as pin 4. Okay? And let me show you how I'll use that. So instead of talking about number 4, which is kind of crude, because I may want to change it later, I can talk about LED 1, you see? And in my random function, I can say current LED is LED 1 through, and it'll end up being LED 8 plus 1. You see? Because I've got to go 1 beyond that pin. I'll leave this as 1 through 11 because I know that I've got 10 interrupt service routine calls, but you could do something similar here if you wanted.
So, in the assignment, it says flashing. You just want it to be on for that amount of time, not like flashing for that amount of time.
Correct.
Okay.
Right. I'm not trying to make it flash for that amount of time. I'm making it on for that amount of
Well, that
time.
makes sense.
Very good point. Well, remember, one of the challenges is to make, and you can make whatever light show you
Well,
want.
I have them all flash.
You have them all flash.
I'm
Okay.
gonna do this.
Yeah, that's fine. That's fine. You can do that. The idea is just to get the user's attention so they'll play the game at one point and to have something that entertains them. Yeah, I don't know about you guys, but in playing video games were almost always a letdown because you'd go through, you'd work through this game, you'd enjoy it, and at the end you want there to be some big story, like a movie at the end that you've earned, right? And they almost never do that. Most of the time it's, congratulations, play again. You know, you go back to the very beginning, like, why did I do this? Anyway, so we want some kind of reward for the user or, you know, or punishment if they don't succeed. So anyway, so I'll continue with this. Again, if you guys want to watch this part, you can. For the sake of the Anderson students, I will record what I'm doing. All I'm doing here is making the code a little bit more readable and easier to change. And then when I'm done with this, I will post the code and you guys can have it and do whatever you want with it. Okay, so I'm going to keep talking for the sake of the Anderson students, so let's see. Current LED, I'm just going to make that LED 1. Again, this is all so that I can change the pin assignments later if I ever decided to for whatever reason. Keeping flexibility is very important. So let's paste a few more where we're defining LED 2, 3, 4, 5, so on. So pin 5, 6, 7, 8. And I'll make my life a little easier by copying and pasting all at once. And let's see, 4, 5, 6, 7, 8. Pin 10, or 9, 10, 11, and 12. LED 6, 7, 8, 9. I missed a count somewhere. 1, 2, 3, 4, 5, 6, 7, 8. No, I've got one too many.
Really?
1, 2, 3, 4, 5, 6, 7, 8. There we go. So now we've got names for the pins, and all we've done is define. The compiler will actually replace wherever it sees LED 1, LED 2, and so forth, it will replace with the numbers 4, 5, and so on. So let me download and run this. We got our pin mode set. Let's download and run this and see if I've done it correctly. It is uploading. let's make sure sound is coming out. We've got sound. I see the high and the lowest LED flashing. I will hold it up so that you guys can see it too if you're watching this on video. Hopefully you can see that okay. I don't have a preview so I can't tell. Hold it back a bit. Hopefully you can hear that the speaker's making the noise it needs to. That's just the good old Mario Brothers theme song playing. Okay, I think that's it.